2, and 4. Were there any others that I missed? You guys can say these ones out loud. Just 2 and 4. And 3. Okay, we'll do that one. Let's see. Okay, for number 2, you had a bunch of different ways you could have started this by moving things or distributing. I'm just going to go ahead and distribute the -3 to both of these things here. It's writing wherever that marker just went, but I can't change it, so. This, you could do this in your calculator or by hand. This would be -3 over 1, so -3 times 5, 1 times 6, to get -15 over 6, and you would simplify that. Divide both by 3. And then plus 6. Then we could combine like terms on the same side, the 5 and the 6. Add those together to get 11. And then from here, you could pick and choose what you wanted to move. So let's say I moved the 5/2 over to the left by adding. If I'm doing that, I'm going to also move the 7 to the right by adding. This, because they have the same denominator and both have 2, I would just add the numerators, 1 plus 5 to get 6. But 6 over 2 is 3. And 11 plus 7 is 18, and we would divide both sides by 3. So that x is 6. Questions on that one? Remember that you can be double checking this while you're practicing in Desmos as well. Put the whole thing in and see what that answer is. In number 3, it was already solved for you. You just need to look at the type of solution you would get. So if at the end you don't have any variables and you get 2 equals 0, what type of solution is that? No solution. How do you know the variables canceled and it's not a true statement? So both of those things would have to apply in order for it to not be a solution. Okay. Number 4 is a little different because it has 2 variables, and really using your previous knowledge of infinitely many solutions is going to help you solve this. So let's say I started to solve this for x by distributing the -2. Now, at this part, if this were an infinitely many solutions equation, these 2 sides would be identical. Right now, they're not. But the -2 is, so I'm no longer going to solve for x, and now I'm just going to solve for k. If these were to be identical, the 1/2 k would need to equal -8. And I'm just going to solve for k here by taking the reciprocal, flipping this 2, and multiplying it on both sides. So that if I were to put this back in, -16 times 1/2 would give me -8, and then they would be the same. So I wasn't really expecting you to be able to get that one because it was a little bit more challenging. If you did get it, great. If you didn't, no worries. Questions on those last 2? So I'm going to show you your Delta Math scores, and then if we have any Delta Math problems we wanted to go over. We'll do that really quickly before we jump into our notes. So you guys had 3 decimaths that were due on Friday. 1 of them was informative, 2 of them were formative. So this one, our multi-step equations, we did not get our 50%. That one is informative. It's not affecting your grade, but you should definitely go back and practice it for the upcoming quiz and test. Then the multi-step equations with variables on both sides, we did meet our 50% goal, but that means many of you are still missing that or have not finished that. That one is affecting your grade, so please go back and do that. Email me once you've done that, and you guys will get gumballs for that in 1 second. But then the real world problems, we did not meet our 50% goal. So many of us are missing that, have not finished that. It is affecting your grade. We need to go back and finish that. Did we have questions on any of those 3 that maybe I can pull up that you weren't sure how to start, how to do, you got stuck, anything like that?
I don't know how to explain it, but it was just fun. It was like percentages. It was talking about like a store.
Okay, so that was in the real world problems. Okay. So in this example, Isabella works in a department store selling clothing. She makes a guaranteed salary of $250 per week, but it's a paid commission on top of her base salary equal to 30% of her total sales for the week. How much would Isabella make in a week in which she made $1,875 dollars in sales? How much would she make in a week if she made X dollars in sales? So it's asking you 2 things. 1, how much would she make if she made this in sales? So important things, we know she makes this amount per week no matter what. So she's always going to get that amount. Then on top of that amount per week, she gets 30% of her sales. So if she made this in sales, 30% of that, we'd have to multiply those 2 numbers together. And you could put this in as 30% or change it to a decimal, which would be 0.3. And we would multiply these and add this and see what we get. So let's do that really quickly. So then 812 should be what she gets based on these sales. 812.50. Okay? So that was the original. If she made this amount, what would her total salary be? Then it's asking, what would that amount be if she made X dollars? So now instead of putting in an actual amount here, that becomes X. Except I'd switch this. The second part is always asking, in general, if I were to find any amount or any whatever, how could I write this as some equation or expression? And you would just take whatever number you were putting in, change that to your variable, and that would be your equation. Questions on that?
you say? Yeah.
So why would the x go when it's even?
Why would the x, say that one more time,
Why? So why is the x go like the 0.30?
and not the 250? Is she getting 250 every time with her sales? No, she's just getting that regardless. So because she's getting that regardless, that's like a y-intercept. Whereas this is like your slope. You're getting that every single time for each per. So that's why the x goes with that. Okay. Other just math questions? Alright, then I need computers put away, closed. Okay, and look at the notes on your desk. So this is the second to last lesson of this unit. The last one will be on Wednesday, and then we're going to review and quiz on Friday for your test next week. Notice that in our learning target, this says A2, while all the other ones just said A. This is an Algebra 2 standard, so this is one of your extensions that regular algebra doesn't go over. So in this, we're talking about absolute value equations and how to solve them. So the steps to do that, first, make sure the absolute value expression is isolated. What does that mean? Alone, by itself. Get it by itself. Okay. Then we're going to set the inside equal to both a positive and negative number. We'll talk about that in a second. Then we're going to solve both equations. And then at the end, we're going to write the answer as a set notation. That looks like this. X, curly brackets, first answer, comma, second answer, least to greatest. And then we're going to get into solving some of these. So, if there was something outside of the absolute value bars, a plus something, a minus something, a times something, dividing something, whatever, we would get rid of that first. But in this case, there is nothing, so that part is done. Then we're going to take the inside, we're going to drop the absolute value bars and set the inside equal to both a positive version of this number and a negative version. Absolute value measures distance. So distance can't be negative. If I walk 5 steps and then I walk back 5 steps, I still walk the same distance. So because absolute value is measuring distance, it can't be negative. But equations can be negative. That's why we drop them and set it equal to both. If this were an actual equation, we would solve it, but there's nothing to solve here. So these are our 2 answers. You can write them as -2 and then 2. Or, because I have the same number in both a negative and a positive, I can put it as plus or minus 2. That's what that symbol is called, plus or minus. Logan, go ahead and shut your computer, please. Thank you. What questions do we have so far? We're going to move on to number 3. So number 3, same thing. If there were something outside of the absolute value bars, we would solve that. But there's not, so we're going to drop the absolute value bars and set this equal to a positive 40 and a negative 40. If you don't set it equal to the negative, you've now lost half of your working answer. And then how would I solve this? Say that again. Division. Divide both sides. Divide both equations by 5. So that z equals what 2 numbers? Say again. 8 and -8, or plus or minus 8. There won't always be a positive and negative of the same number. It depends on the equation. Any questions on that so far? Yes, Evan.
I know the rest.
Yes. Alright, now we're going to skip to number 5. Same thing, it's already isolated, so go ahead and drop the absolute value bar, set it equal to a positive 8 and a negative 8. And then, how would we solve this? Add 1, or subtract 1 on both sides, yep. What are the two solutions there?
7 and -9.
In order, -9 and 7. Questions here? I do want to note this. 6 is similar. We would not change the minus inside the absolute value to a plus. We would just change the core to a negative and a minus. Okay, let's try 7. Right. Again, it's already isolated, so we don't need to do that part. Drop the absolute value, set this equal to a positive 34 and a negative 34. And then how would we solve this? Subtract 2. So we have 4n equals negative 36 and 4n equals 32. And when we divide both, what are those two answers? Say it again.
8 and -9.
Okay, in order, -9 and 8. Questions on that one? Are there any others on this side that we want to see do go over before we go into the back? If not, go on to the back. Okay, in all the previous problems, we didn't actually have something to, we didn't have to isolate it. But now we will have things outside of the absolute value bar, so we will isolate the absolute value bars. So when we do this, we pretend whatever is inside the absolute value bars is like our variable that we're trying to solve for. We don't do anything with that until the very end. So what would we do here in number 9? Okay. So when we do this, this needs to stay in absolute value bars until it's completely isolated. So until we get to this step. Then, once it's in that step, then we can drop the absolute value bar and set it equal to a positive and negative. But in this case, there's nothing to solve. Actually, let me not do that. I'll do this first. So I would set it to a positive and negative, and then there's nothing to solve, so that would just be my answer. So you would isolate it first, get it by itself, then drop it and set it to the positive and negative, solve it if necessary, and then get your answer. Let's try 11. How would we start solving that one?
Divided by 6.
So it's now isolated. Now we can drop it, set it equal to both a positive and negative. In this case, there's nothing to solve. Those are my answers. Questions so far? Yes.
Do we have to do like the plus and minus for?
You could
we write
put
it out?
-4, then +4. Okay, let's try 12. What would be that first step? Say again. divide, yes, just like 11. Avoid distributing because these are not parentheses. This is something I can't do anything inside until this is gone. So divide both sides by -2. Now it's isolated. Now I can drop the absolute value bars and set it equal to the positive and negative. And now we can solve by doing what? Not adding, but subtracting. So z equals what two numbers? Say the first one. -4. I'm sorry, +4 is one of them, but this one gives us -4. -10, yes. What questions do we have on that one? Yes.
So how do we get to -10?
-7 minus 3. Okay. Let's try. Actually, I want you to look at numbers 13, 14, 15, 16. Which of those would you like to see do go over and have questions on? Okay. And 13. Okay. 14 and 15 are very similar to 16, so if you can do 16, you should be able to do 14 and 15 as well. So with 13, what would be our first step? Multiply both sides by 6. Get rid of this denominator so that those cancel. This stays in absolute value. And we get 18. And then what would we do from there? Someone started to say something, I just couldn't hear what you were saying. Okay, take out the absolute value and do what with that? I didn't hear that. Say that again. Okay. So that becomes 22. We're missing something. Yes, for this part we're still missing something. Don't we have a negative? We should have a negative. When we do this at the beginning, we need to automatically create the second equation. If you wait until the end and solve this one and then just make this negative, you will not get the right answer. So what are our two answers? One is 11, and the other -7. Questions on that one before we do 16? What do we feel would be the first step in 16? If you were thinking do something with the 3 paths, don't. Because you would have to do that to every single number. It would give you fractions everywhere. You don't want that. So get rid of whatever's adding or subtracting first. Then we can get rid of the 3/2 by doing one of two things. It's multiplying, so the opposite would be to divide, but because it's a fraction, we want to start not doing that, not dividing by fractions, but taking this, flipping it, multiplying by the reciprocal on both sides. Right now, you could still divide by fractions, but moving forward, I would want you to avoid doing that. From there, we can then do what? As is. So like this. We have to drop the absolute value. This can't equal a negative. You have to drop the absolute value before you create your negative case. Equations can equal negative numbers, but absolute value equations cannot. And then let's solve them both. By doing what? Adding 4. You're going to get fractions for both of these. So when we divide by 4, what are those two fractions? What would those two fractions be? 1/2 or 0.5. It's a nice decimal, so you could put either or. And the other one? In a improper fraction. Or 1. So if you do get fractions that maybe aren't nice decimals, leave them in fractions. If you're not sure which one is bigger, divide it to see what that decimal would give you. To see the order. Questions on that one before we talk about these special cases? Least to greatest. Okay. So all this time as we were talking about absolute value equations can't equal a negative. So if you get something where it's isolated and it equals a negative, there is no solution. You can't solve it. Now you may get some equations that have negative parts in it, or maybe it does start off with a negative, so like in 16 it had a negative, but as we were isolating, it became a positive. That's okay. But if you start off and this part is isolated and you equal a negative, you cannot do that. That's no solution. But solve it regardless, because maybe you won't know until you get there. So like in this case, how would I solve this? Divide both sides by -3. And at this step, this is isolated, but this equals a negative, so I can no longer solve this. It's no solution. Because it equals a negative number. So the reason isolated absolute value bars cannot equal a negative.
I'll say expressions actually. I will say one more thing before I let you guys practice. On the very back, number 16 is very similar to the one we just did. However, instead of the plus 3 at the end, how our 24 is, it's at the beginning. Do not combine those. It's just, they just moved that 3 around. So it's very similar to this one, except the 3 that they have is in front. So you would still get rid of that 3, just like we did for this 24. Okay, I want you guys to be able to practice this. So you guys have a delta math on this, let's do on Friday. Do that delta math, do the discussion on this, and then after you finish those both, you could be working on retake work, missing delta math, finishing tests if you need to. Okay, questions on what we're doing for the rest of the class? You guys can work together, move around, but be working on the absolute value equations, delta math.